Welcome grade 11th and grade 12th to this lesson, which is on functions. And basically, we are going to look into the hyperbolic function. All right. So please kindly check the other sessions, which are on the linear function or the straight line function, the parabolic function, as well as the exponential function for grade 11th. Then grade 12th, also check the logarithmic function and the cubic function sessions. Okay, so we are dealing with the hyperbolic function, which we usually just call this function the hyperbola. Okay, so we need to check everything that has to do with the hyperbola and make sure that we are understanding what we are doing when we start looking into a hyperbola. Okay, so a hyperbola is a two-piece function, very important. So that means a hyperbola will be having two pieces, okay, as a function. One piece will be on the first and the other one will be on the third quadrant. So we will be having the two pieces, one on the first quadrant and one on the third quadrant, or we'll be having one piece on the second quadrant and the other one on the fourth quadrant of the asymptotes. Okay, very important. These quadrants are created by the asymptotes. Okay, we're not talking about the quadrants that are created by the Cartesian plane. These ones are the quadrants that are created by the asymptotes. Okay, now how will the asymptotes create these quadrants? Okay, so they are able to create these quadrants because we've got two asymptotes for a hyperbola. Okay, the hyperbola has a vertical asymptote and has a horizontal asymptote. Remember, an asymptote is an imaginary line that a function or a graph will approach but will never touch or cut or cross. Okay, so a hyperbola has two of such imaginary lines, a vertical one as well as the horizontal one, okay, which are given by the equations x equals to p and y equals to q, where p and q are the vertical and horizontal asymptotes respectively. Okay, now with a hyperbola will have one x-intercept, very important, and will also have one y-intercept. Okay, so there will be a single x-intercept and a single y-intercept. And it's very important to note that each of the two pieces, okay, each piece of the function will be responsible for these intercepts. What we are saying is one piece will cut the x-axis and the other piece will cut the y-axis. Okay, very important. Hence we have one x-intercept and one y-intercept. Okay, also the function, okay, the hyperbolic function is not defined at the asymptotes. Okay, remember we are saying an asymptote is an imaginary line. So in that case, it means at these imaginary lines, the function will not be defined. Okay, the function is undefined at those particular points. Okay, also with a hyperbolic function, okay, a hyperbolic function has two axes of symmetry. Okay, remember what are axes of symmetry? These will be your lines of symmetry that will cut the hyperbolic function into two equal parts that will form mirror images of each other. Okay, so with a hyperbola, there will be two axes of symmetry or two lines of symmetry. Those are lines that will cut the hyperbolic function into mirror images of itself. And very important, the hyperbolic function, okay, since we said it will have two axes of symmetry, what is also going to happen? These axes of symmetry will intersect, all right, at the point of intersection of the asymptotes, meaning they will cross each other at the point where the asymptotes are meeting each other. Okay, remember the vertical asymptote and the horizontal asymptote, they will be perpendicular to each other at the point of contact. So that is what we are saying when we say they intersect these axes of symmetry at the point of intersection of the asymptotes. Where the asymptotes meet, that's where they will also be intersecting. Okay, they will be crossing each other. Moreover, since we've got two equations of the axes of symmetries, then it's very important to know that the gradients of these equations of the axes of symmetry will always be either 1 or a minus 1. Okay, very, very important. When we are dealing with the equations of the axes of symmetry, the gradient will either be a minus 1 or a 1. Okay, depending on the specific axis of symmetry that we are dealing with. Okay, so having said that, we want to look at the equation of axis of symmetry with a positive gradient. Okay, remember those axes of symmetries, they are straight lines. So it means we're gonna use the equation of a straight line where our gradient will be a positive 1. Remember, I said the gradients of the axis of symmetry of a hyperbola will always be 1 or a minus 1. So when we are looking at the gradient where it's positive, which is positive 1, using the equation of a straight line, since the axis of a symmetry is a straight line, then we have y equals to x plus c. And for us to find c, then it means we'll be substituting the coordinates of the asymptotes. You agree with me? Now, let us look at the equation of the axis of symmetry with the negative gradient. Remember, the gradient in this case will be m equals to minus 1. Using the same equation of a straight line, we'll be having y equals to minus x plus c, where if you want c, we can then substitute the values or the coordinates of the asymptotes. Okay, so the coordinates of the asymptotes will be given by the vertical asymptote and the horizontal asymptote. So we put them, or we give them as a coordinate, and we substitute them in the equations of the axis of symmetries in order to find the value of c. Okay, now also very, very important, the axis of symmetry will cut the hyperbola. Okay, this is very, very important, at 2 points. Okay, so remember, if I have my hyperbola, the hyperbola will either be in the first quadrant and the third quadrant of the asymptotes. And then if then that's the case, it means my a will be positive, and it means I'll be having a straight line that is an increasing function. So as a result, it means there will be 1 point in the first quadrant that is intersected by the axis of symmetry, and another point that is intersected by the axis of symmetry line in the third quadrant. Okay, so that's why we are saying the axis of symmetry will cut the hyperbola at 2 points depending on the shape of the graph. If now our hyperbola is in the second and the fourth quadrants of the asymptotes, then there will be 1 point in the second quadrant and 1 point in the fourth quadrant where the hyperbola is intersected by the line of symmetry, or the axis of symmetry line. Okay, that's very, very important, but that all depends on the shape of your hyperbola. Moreover, we can be able to find the equation of a hyperbola. Remember, every function has its own rule or its own formula. Okay, so the equation of a hyperbola is given by y equals to a over x plus minus p plus minus q. Okay, let us look at each of the variables that we get from this equation here and try to understand them. So what is the function of a in this equation? Very important. Your a determines the quadrants that the hyperbola will lie in. Okay, very, very important. So it means your a here, depending on whether it's negative or positive, will tell you which quadrants the two pieces of the hyperbola will lie in. Okay, among the quadrants. So a determines where the two-piece function will lie in. Okay, given the quadrants between the asymptotes. So on that same note, it means when my value of a is positive, okay, then the hyperbola will lie in the first and the third quadrants of the asymptotes. Please take note of the asymptotes, not of the Cartesian plane. It will only be the Cartesian plane if our vertical and horizontal asymptotes are 0. Okay, so in this case, we are saying if your a is positive, then we will be having our hyperbola in the first and the third quadrants of the asymptotes. Okay, so you'll be having your asymptotes perpendicular to each other. Then in the first quadrant of the asymptote and the third, we'll be getting our function when a is positive. Then when a is negative, less than 0, the hyperbola will lie in the second quadrant and the fourth quadrant of the asymptotes. Very important. Okay, which is the opposite of what we've just spoken about in the first, previous point. Okay, so what is P and what is Q? I think I've already said it. Your P is your vertical asymptote. Okay, so when I take this part from here and I equate it to 0, then I solve for x. X will be equals to the value of P, where the value of P will be our vertical asymptote. And then when you say y equals to the value of Q, that gives us our horizontal asymptote. And these will be the two asymptotes that will be having, creating the four quadrants between the asymptotes and determining where the two-piece function will lie in those quadrants. Okay, very, very important. And then now, next up, also it's important that we may have some shifts in the graph or the function. Okay, we may shift our function either to the left or the right, and that will be given by P. Okay, so whenever we change P to either move to the left or to the right, then we say P is responsible for the shifting of the graph vertically. Okay, should be the opposite. Okay, this should be the opposite. Okay, yes. So P shift the graph vertically. I hope that is very, very important. Okay, so okay, let me do this. With regards to P, it's very, very important that we fix this one here. P specifically will be responsible. P will be responsible for the shifting horizontally, not vertically. Okay, where's this thing? Okay, so P will be responsible for the shifting of the graph horizontally. Okay, horizontally, because we are talking about the x values. Okay, and then Q will be responsible for the shifting of the graph vertically. Okay, apologies. Now, since we have that, we are now happy. And then let's go back to A and just talk about A. Remember A, we said it tells us which quadrants our two-piece function will lie in. So if our A is positive, okay, we said our two-piece function will lie in the first and the third quadrants of the asymptotes. And as a result, our line of axis of symmetry will intersect the two pieces at 2 points. 1 point in the first quadrant, another point in the third quadrant, and as a result, the equation will be y equals to x plus c of the axis of symmetry. Okay, so which points will the axis of symmetry cut the hyperbola at? So those points will be given by this part here, okay, where you take the root of a plus p is to root of a plus q, where p and q are your asymptotes, okay, and where the root of a coming from the formula, the equation. So remember, since we see that both of these values here, or both of these coordinates, they are positive, that means this will be the one in the first quadrant where both x and y are positive. And then here we have a negative x and a negative y. That means this will be the coordinates in the third quadrant where both x and y are negative. Okay, this is very, very important. So these will be the 2 points that are intersected by the axis of symmetry. And then also, if a is negative, then it means our two-piece functions will be in the second quadrant and the fourth quadrant, and there will be 2 points that are intersected by the axis of symmetry, where its equation will be y equals to minus x plus c, and the 2 points, remember, in the second quadrant, x values are negative, y values are positive, and this will be the point, okay? And then in the fourth quadrant, the x values are positive, y values are negative, and this will be the point of intersection of the axis of symmetry and the hyperbola. Okay, well done. Now, this is what we are having. Which is your negative root a plus a p, negative root a plus a q. And then in this case where a is negative, we are saying the axis of symmetry will intersect with the hyperbola at this point there and this point there. Okay, and then you can check the point where you will be substituting. Okay, very, very important. When we are dealing with these, finding these points, okay, it's very important to note that the sign of a is not taken into account when calculating the point of intersection. So even if from the equation a is negative something, the negative you don't actually put it under the root. You only take the value of a, not the sign of a. That is very, very important when you are determining the point of intersection. Now, how do we sketch the hyperbola? Very important. I've written some points for you here. When we sketch our hyperbola, as you will see when we do exam questions, remember, here I'm only delivering content, then there will be a session where we'll be doing questions on parabola, hyperbola, linear function, and exponential function. So the first thing that you need to do when you're sketching a hyperbola is you must determine the vertical asymptote and the horizontal asymptote. Put that on your cartesian plane and dotted lines, okay, vertical and horizontal. And also next up, you must determine the quadrants in which your function lies, meaning look at the value of a and the sign. If it's positive, if a is positive, then your two-piece function will be in the first and the third quadrant of the asymptote. Then if a is negative, then your two-piece function will be in the second and the fourth quadrant of the asymptote. Okay, then the point is you must determine the x-intercept by letting y be equals to 0. Similarly, determine the y-intercept by letting x be equals to 0. Okay, and then the fourth point is you should also expect questions, because they usually give you, sometimes they don't give you. Expect questions where you need to determine the equations of the axis of symmetry, okay? And also where they say find the points of intersection of the axis of symmetry and the hyperbola. this is what you will need. Okay. Remember your A value will guide you, okay, which consonant will be written in all this. So thank you very much for watching this session. Also, I'm going to you to watch the lesson on exponential function, okay, which is the last function for grade 11 that I'll be covering for the 10th. But however, for grade 12, we still have two more, which is the logarithmic function and the trig function. We also need to check those questions. Okay, your exponential function follows immediately after this one, and please don't forget to subscribe. Like, if with yourself and